and welcome to our Group 14 robot presentation. Our team consists of Jonathan, who is in charge of the robot design and robot assembly, Tom, who ensured correct power distribution and circuit design, and Ben, who is our main software programmer, constantly debugging and ensuring the correct movement and state of our robot. The robot arm has quite a different look from the initial design, shown on screen, due to one main issue. We needed to add a wall/lever for the back of the pinion to rest upon. Our new design included this. Instability of the robot was also improved upon from the original design with the addition of a couple of L brackets especially designed to fit the robot base and maintain the structure of the arm. The strength of the robot arm was also given a massive boost by a new stepper motor included in our build. This meant a faster and better service to the rack and pinion. Once again, the original design was changed. A more practical and efficient gripper was designed with the addition of a third arm. Two arms would be stationary, with the third being the rotating arm. This would mean the gripper would have a higher chance to correctly pick up the puck. Not only was a third arm added, but also rubber bands to each arm, as the friction of the material would mean a better grip on the puck. When trialling the color sensor circuit, we definitely were able to get the correct result wanted. However, the consistency of each result was not where we wanted it to be. To overcome this, we decided to implement the same color sensing test as before, but now it would run 5 times in a very quick loop. Each test would consist of taking analog values measured by the photodiode of the red, then green, then blue light bouncing off the puck. This test would run 5 times in quick succession, sum all values of the red, green, and blue light from each test, and assume the highest analog value was the correct color of the puck. The main 3 uses of the ultrasonic sensors included were the range finding, wall alignment, and obstacle detection functions. The range finding function would utilize the front 2 ultrasonic sensors, constantly measuring the distance from the wall to each sensor. Once the sensors both detected that there was a wall in front of the robot from a set distance away, it would attempt to realign itself perpendicular to the wall. It would do this by seeing if one sensor gave a higher calculated distance than the other. If so, the robot would turn to correct itself, attempting to equate both calculated distances, such that the measured distance of both sensors from the wall would both give the same result, with a little room for error in a given range. Wall alignment would utilize the right sensor and be activated once the robot is driving to the other side of the arena, in an attempted straight line. Once this function starts, it tells the robot if it is in one of 3 states: too close to the wall, too far away from the wall, and a good distance from the wall. Each state would make the robot react accordingly, i.e., if too close to the wall, make the robot veer further away. Vice versa, if it's too far away from the wall, make it get to a better distance. And if it is in a good state, make the robot stay and veer in a straight line. Obstacle detection again utilized the front 2 ultrasonic sensors and would see if after it turned the corner, if there was a wall detected within the first 70 centimeters. If an obstacle was detected, it would run a different path to get to the pucks. When trialling all 3 states, sometimes the robot would make an error and be quite hard to debug as the error was unknown. To overcome this, we decided to implement the LED sensors on the left to tell us when it was in one of these 3 states. We also added a board state telling us when the robot would not align properly in a given time. We decided to plan out every possible configuration of the obstacle and puck and make sure that the robot had different ways to overcome each arrangement. The ultrasonic sensors were again used to find its way to the construction zone. Then repeat this algorithm 2 more times once the puck had been dropped off. After 3 pucks had been picked up, a new algorithm would commence to make the robot return to base. The gripper could be thinner to make sure it's not hitting other pucks. The weight distribution was quite forward heavy, causing traction to the robot. Better ultrasonics. This could allow for more uses on puck detection and less error involved with wall detection and wall alignment.